Thank you for following Makeover 2012. One of the single most important things that we do with the Makeover is educate. We want you, the Electric Cooperative of Arkansas member, to learn about the basic concepts of building science. And one of the most important areas is an area of heat transfer, heat gain and heat loss. And we use a neat gadget to do that. It's called an infrared camera. And it helps us to detect the way heat is emitted off certain items. And with the Makeover, obviously it's the way building materials react to heat. And so we are going to take a look in this segment at certain materials in your house and what happens when the sun heats those up, or what happens when electricity heats those up. We mentioned previously that heat always moves to cold. It's a law of nature here on planet Earth. So let's demonstrate how that law applies within the Makeover home. We know that based upon our infrared camera, the temperature of the wall is about 77 degrees. And then of course a human body is about 98.6. So we have a delta T, or a temperature difference here, of about 20 degrees. So let's demonstrate how the heat from my body will transfer to a cooler area. So the infrared camera shows us that the temperature from my body transferred to the wall behind me. So let's take that a little further and learn a little bit more about building science and how we can improve the comfort in our houses and lower our utility bills. We are in one of the bedrooms of the Makeover house. Looks just about like any other bedroom across America. We have a latex painted wall, a lightly sprayed popcorn ceiling. But our comprehensive audit and infrared thermal imaging camera revealed a serious situation in this room, and not just here, but around the entire perimeter of the house. This is an outside wall, and this wall goes up and meets the roof line. And what we discovered is when the house was originally insulated in the 1950s, and then later on somebody came back and added a little bit more insulation, but because the nature of the roof is like any ranch-style house, the area where the roof comes down and meets the wall is very narrow up there, so it's very difficult for a human to get up there and work. So what happened is the insulation contractor did the best he could and applied a little bit of insulation there. But there are several areas throughout the house that have no insulation, and the infrared images clearly indicate there are places where there's no insulation. So what does that mean? Well, again, heat moves to cool. So on a hot summer day in Arkansas, the heat around the entire perimeter of the house was gaining access through conduction and radiation into the home. It made the air conditioner run much harder than it needed to, and it created an uncomfortable environment while it was raising the utility bill. So the solution is Tommy Gracie with BPSI will be coming in to apply the open cell foam insulation to the roof decking, install the retro foam insulation between the brick veneer and the subsiding, and a combination of those two will fix the problem. We are in the dining room of the Makeover house, and you'll notice that the chandelier over the kitchen table has fixtures for 8 light bulbs. And we've taken the sconce off of one of the light bulbs so it would expose an incandescent bulb. And what we know through building science is the amount of energy it takes to light a standard incandescent bulb. 90% of that is in the form of heat, and 10% is in the form of light. Now, fortunately here at the Makeover house, they only had half the amount of lights going. And so let's talk a little bit about what those lights are doing. And as we pan down to the infrared camera, we have it focused on the bulb that the sconce has been removed from, and you'll note that the temperature of a 40-watt bulb is almost 190 degrees. So imagine if we had all 8 of those burning and putting that heat gain into the house at 190 degrees. This is one of the reasons that homes are very uncomfortable, is because the amount of heat generated from light is being dumped into the house creates a tremendous inefficiency, causes the air conditioning to run much longer to remove the heat that's being produced by light bulbs. So what's the solution? We recommend changing the bulbs out to a compact fluorescent lamp or LED lamps. They use far less energy and they burn at a far less operating temperature. During a hot summer day in Arkansas, one of the last things we want to do is create heat in our house. A culprit that exists in just about every home in Arkansas is a ceiling fan. We enjoy that comfort of the convective cooling that we feel from the ceiling fan, and it's evaporating the moisture off of our skin, which feels cool to us, to our human body. Well, that's what a ceiling fan's doing. However, in the process, the ceiling fan motor is generating heat. So remember, heat moves to a cooler environment. Also, if the ceiling fan has a light kit, the light itself is also creating heat along with the motor, so both of those can be contributing to the amount of heat in the house. Meanwhile, the air is moving across our skin and it feels comfortable. The infrared camera confirms that the ceiling fan temperatures that are being emitted are ranging between 140 and 80 degrees. Again, one of the last things that you would want to do in your house when you're trying to cool it is to contribute by adding heat into the house. So be mindful when using ceiling fans.